All right, so here we're going to look at graphs that approach a specific value, okay, not always infinity. So here, so it's not going to keep going, it's not going to go down as you go to the left or go up as you go to the right. It's going to approach a certain number, an asymptote, okay. So let's look at this one. Use the graph of f of x equals x plus 2 divided by x squared minus x minus 2 to describe the end behavior. Support the conjecture numerically. So again, we're going to use the graph to describe it. So as the x is approaching negative infinity, as you're going to the left forever, notice that it's not going down, it's approaching a number. It looks like it's straightening out. And what is that number? What is that y value? That's 0. The y is 0, right? Okay, so you would write as x approaches negative infinity, as x goes to the left, f of x, the y, approaches 0. So it gets closer and closer to that x-axis, that 0. Oh, sorry, f of x approaches 0. Oops. That's an arrow. All right. And let's look at the right behavior. So on the right side, as x approaches positive infinity, f of x, and it looks like it's approaching 0 here as well, right? Approaches 0. Ta-da! And that's it. So that's how you can tell using the graph. Okay, so you have to see what it's approaching. It's not always going to be 0. Okay. And now we're going to support it numerically. So again, we're going to do our table. So here's our table. X and XY table, or XFX table. We just need 5 points again. Alright, now in the middle we have 0. If you plug 0 in here, 0 plus 2 is 2, and divided by 0 squared is 0 minus 0, so we have 2 divided by negative 2, which is negative 1. Alright, and again, like before, we need numbers that are approaching negative infinity, and numbers that are approaching positive infinity. Oops. That was a bad infinity sign. Oh well. So here, like before, we're going to use negative 1,000 and negative 10,000. And on the right side, we're going to use 1,000 and positive 10,000. Now, do we always have to use those numbers? No. We're just using that because those are nice numbers, okay, that are multiples of 10. So it's easier to work with. All right, so let's do it. So to find the y's, we have to plug it in just like before. So f of negative 10,000 equals, and we're going to substitute all the x's with negative 10,000. So negative 10,000 plus 2 over negative 10,000. And this one, because it's a negative squared, you have to put parentheses around it, minus, and since we're putting the negative number inside, we also have to put parentheses around that, minus 2. All right, so let's use our calculator for this one. All right, so for this one, if you're using Desmos, you don't need the, actually I think you do need the parentheses, but for the scientific calculator like this one, you do need the parentheses for the numerator and the denominator. So let's put parentheses first, and then 10,000 and make it negative plus 2, close parentheses. Okay, so that's what that is, divided by, and then here we're going to need 2 parentheses, so for the denominator, 1, and also because of that negative 10,000 inside the square, so another one. So 10,000 negative, close parentheses, square this one, minus, and then here we need just 10,000. We don't need to put parentheses for this. You can if you want. Then negative minus 2. Now don't forget we had the parentheses in the beginning, right? So close the parentheses to let the calculator know that's the denominator. And then equals. Ta-da! And look at that. You get negative 9.9970005 to the negative 5th power. Okay, so we usually round to the nearest hundredth. So because that's a 9, okay, and this is a 7 after it, so it's larger than 5, so we have to round up. So this becomes a 10, that becomes a 10, that becomes a 10. So this is actually This is actually 0.9997 times 10 to the negative 5. This is actually rounded to negative 1.0 times 10 to the negative 6. Okay. So we're actually increasing this one, or decreasing it, as I say, because we're rounding up. All right, and then I'll use the calculator to calculate the rest. And there we have it. So as it goes to the left, as x approaches negative infinity, look at the y, it keeps getting smaller and smaller. And notice that negative exponent. So remember here we had a positive exponent. That means it's approaching like a negative infinity. Okay, but here because we have a bigger and bigger negative exponent, that means the number is actually getting smaller and smaller, like a fraction or a decimal. Okay, so it's negative 0.00001. Right, keeps getting smaller and smaller fraction, so it's approaching 0. Ta-da! So eventually it's going to approach. It's approaching 0. Never going to touch though. All right, same thing over here. Here keeps getting smaller and smaller, right? It goes from negative 3 to negative 4, and then negative. Who knows what's next, right? Keeps getting smaller and smaller. So it's going to be approaching 0 here as well. Ta-da! So this is correct.